In a previous video, we discussed about light curve generation for GRB 120709A. We saw how we can extract the DAT files from RMFIT directly and how we can use Python to plot it. And this video is in continuation with that video. In this video, we will be seeing how we can calculate the duration of the burst, or the T90. The T90 duration for a GRB is defined as the time during which the accumulated count or accumulated energy for the burst goes from 5% to 95%. So there are two ways, or there are two calculated T90s that are often used. First is for the complete duration of the burst, that covers the entire emission episodes in GBM, and then there is the T90 calculation for the emission episodes. For example, this is the light curve for GRB 120709A. As you can see in this part, there are three emission episodes separated by white episodes of almost no emission. So let's say we want to determine the total duration of this burst. What we will do is we will calculate the T90 duration of this total duration. And if we want to calculate the T90 for the episodes, we will focus our code on this one, or if you want to calculate for this one, and then so on and so forth. So for this purpose, we use this code light curve functions. It has a function get detected data. We saw this in the previous video as well. So this is basically, you give a DAT file to this function and the low and high energy for what you want, from whatever energy range you want to get your data from, and this gives you your required data. So this is the initialization part. We are initializing our variables. Then here the code reads the data file. This is the separation of energy channels and the data from the DAT file. If we look up this one, as you can see, this data is irrelevant to us. These are the energy channels, or what are used in, for example, this case GPM, and then this is the data from here to the very end. So here we are separating the energy channels, and then we are separating the data for us to be working with. And this section of code deals with splitting the data into different columns. We discussed the columns in the previous video as well. We have the energy, we have the time duration in the first two columns, then there is rate, rate error, background error for channel 1, and then rate, rate error, and background error for channel 2, and so forth, so on and so forth. We change the data to an array, and then we get the lower limits of the time for every interval that is stored in the file. Here we split our low and high energy channels. We read the data error, the background, and the background error, and this line returns all these things back. The other function in this file is the get mask file. As you can see, it is a logical AND function. What it does is it masks the data between two time durations specified. Then there is plot T90 curve, which is explanatory in its name, that it will plot the curve based on the time, the rate, the starting and ending time duration. It first calculates the sum of the rate given and then the cumulative sum. Then it normalizes it with the median of cumulative sum. When this function plots it, these are some lines to show the boundaries of current time restraints. This is the mask for 5% and 95% calculations, and then we apply the mask to our time duration as well. Then we plot it with respect to the values that we have. Next, we take a look at calculate T90 curves. This is the main function that we'll be using the light curves function in it to generate the required T90 plots and using it to generate the data. So the first thing that we do is we define the T05, T95, and an extra parameter. T05 is the starting duration for the GRB, and the T95 is the ending duration for the GRB burst. These two values are taken from Ajello et al. 2019 paper, the LAT catalog paper. And then this extra duration here is the duration that we will specify for the program to take into consideration when calculating the T90 duration. This parameter is subjective and every user can have different approach to the time duration. In this example, I have set the extra to 5.376 seconds. So what it means is that whenever I will be calculating T90 duration, I will take an extra 5 seconds from left and right of the starting and ending duration for my emission, since I am calculating the T90 for the emissions in this case. So for that, I have episode start and episode ending times. For the first emission, we have the duration from negative 0.128 to 3.648, then 10.432 to 15.232, and then 21.184 to 24.32 seconds. These are the energy channels that we want to specify. We want to know the T90 duration for the burst in 10 to 900 keV. We can use this. If we want to calculate, for example, from 10 to 400 keV, we can change the high energy range. This particular example, I am using only GBM detectors for the 3 episodes. So what we are doing here is that we are taking the episode starting, episode ending time, and this one, whatever episode it is, we are passing the detector dat file in the get detector data with ELO and E high that we have defined here. It gives us the time range and the rate error, background and background error of the dat file. Then we mask the data to exist between the episode start minus extra. As I said, the extra time is the time duration that we are taking to calculate the T90 duration in addition with the episode starting and ending time. So we reduce the starting time and then we increase the ending time to have more counts in order to get accurate results. Then we mask all of our things. We mask our time, rate, background, rate error, and background error. Then we remove the background from the count rate, and then at the end we plot the T90 curve with time, working rate, the starting time, the ending time, the axis on which we will be drawing, and the detector file. And after that we save the files in a PDF and PNG format. So let's see how it works. We open up our terminal. As you can see, it has now produced the for first episode. It has produced the T90 calculations from 10 keV to 400 keV. Similarly for episode 2 as well, and then next it will calculate it for episode 3. So let's open up our PDF. Here you can see that the plots are showing the N6, N7 and N9 detectors as we have specified. This T start and T stop duration are those that were taken from the burst from the LAT catalog, and then 5% and 95% calculation time durations belong to the calculations that we have just performed by taking the extra time as well. So in this case, there are significant differences between the calculations. For example, here we can see T start is from negative 0.128 to 3.648. However, according to the calculations for T90, the time duration for this particular emission episode should be from negative 0.128 to 7.36 seconds. Similarly in this case and similarly in this case as well. So this shows a difference between like taking a visual guess and taking a calculated guess on the duration for the emission. Now if we open up the episode 2, again there are a little bit discrepancies in the calculations. If you want to change the duration, for example from 10 keV to 900 keV, we can do that as well. We will just change the high energy value and then we will go to our terminal and run the code again. Now it will generate the same T90 calculations but for different energy range. If we open them side by side, we can see what differences can the energy make. So here we have so in episode 1 10 to 400 kV and episode 1 10 to 900 kV, both of these durations are same for episode 1. Now let's take a look at episode 2. These are also the same. And for episode 3, this is a little bit changed from 0 second to 5.696 second, and this is 5.632 second. So there is a minute difference of some seconds or some milliseconds in the calculation for T90 in our second in 10 to 900 keV energy range. Similarly, if we take a look at episode 2 for these energy ranges, here the from 10 to 900 kV it is from 8.512 to 15.296, 8.512 to 15.36. In this case, the 10 to 400 kV emission is like giving a broader time range. And for the second episode, we have 9.216 to 16.576. These are both the same. And for the third emission episode, we have 9.6 and 14.967 on 10 to 400 kV. However, we have 9.472 to 17.344 seconds in 10 to 900 duration. So the most affected episode in 10 to 900 kV and 10 to 400 kV is the episode 2 for N9 detector. So this will be it for this video. Thank you for watching.